Hello friends, I am D R Patil. In PUC first year, you have studied gravitational force, Newton's gravitational force. According to Newton's gravitational force, the force between two bodies is directly proportional to product of their masses and inversely as the square of the distance between them, or F equal to G into m1 m2 upon r square, where G is constant of proportionality and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. You have studied in the first year. And here Coulomb's law, it is the force between 2-point charges. It may be repulsive or attractive, but gravitational force is always attractive in nature. And one similarity here, gravitational force is inversely proportional to square of the distance between the bodies, and in Coulomb's law also the force is inversely proportional to square of the distance. And both the forces, that is Coulomb's force or electrostatic force and gravitational force, both are acting along the line joining their centers. Hence, these are called central forces. These are called central forces. Now we start Coulomb's law. According to Coulomb, the force of attraction or repulsion between 2-point charges is directly proportional to the magnitude of charges and inversely proportional to the square of the distance between them, and the force acts along the line joining the centers of two charges. This is a statement. Now consider 2-point charges plus q1 and plus q2 separated by a small distance r, and now consider two unlike charges, that is plus q1 and minus q2 separated by the small distance r. Here the force on q1 due to q2, it is in this direction because these two are like charges, therefore q2 repels q1, therefore direction of force on q1 is F12, and q1 repels q2, therefore force on q2 due to q1, it is in this direction. Therefore, according to Coulomb's law, force on q1 by q2 is F12. It is proportional to q1 into q2 upon r12 square. r12, that is the direction of displacement vector. It gives the displacement vector from q1 to q2. And force on q2 due to q1 is F21. It is also directly proportional to the product of magnitude of these two charges and inversely as the displacement vector or distance between them. But for point charges, F12 equal to minus F21. Therefore, in general, Coulomb's law can be written as force is directly proportional to product of q1 and q2, and F is inversely proportional to square of the distance between them, or summing these two, F is proportional to q1 q2 upon r square, or F equal to k into q1 q2 upon r square. Here K is proportionality constant and its value depends on the medium in which charges are placed. For SI system and for air or vacuum, the value of K is equal to 1 upon 4 pi epsilon naught. 1 upon 4 pi epsilon naught. Newton meter square per coulomb square. Here we know that F equal to K into Q1 Q2 upon R square. Therefore, K equal to Fr square divided by Q1 Q2. That is Newton meter square upon coulomb square. Hence, Newton meter square per coulomb square. Here, epsilon naught is called absolute permittivity of free space or vacuum. Free space or vacuum. This is Coulomb's law. Very important for 3 marks. State and explain Coulomb's law in electrostatics. The force of attraction or repulsion between 2 point charges is directly proportional to the magnitude of product of these two charges and inversely as the square of the distance between them. And the force acts along the line joining their centers. Now, SI unit of charge. We know that SI unit of charge is Coulomb. Then to define Coulomb, we use Coulomb's law. According to Coulomb's law, F equal to 1 upon 4 pi epsilon naught into Q1 Q2 upon R square. And for Q1 equal to Q2, that is equal to 1 coulomb if two identical charges of 1 coulomb are placed 1 meter apart in air medium. Then Q1 Q2 equal to 1 coulomb and R equal to 1 meter. Hence F equal to 1 upon 4 pi epsilon naught, where epsilon naught equal to 8.854 into 10 to the power minus 12. And substituting all these values, 4 pi is 3.142, epsilon naught is 8.854 into 10 raised to minus 12, we get F equal to 9 into 10 raised to 9 Newton. Therefore, 1 coulomb is that charge placed 1 meter apart from an identical charge in air medium. It repels with a force of 9 into 10 raised to 9 Newton. For 1 marks, it is very important. Define Coulomb. 1 coulomb is that charge placed in air medium from an identical charge 1 meter apart. It repels with a force of 9 into 10 raised to 9 Newton. And for this session, we have 3 marks, 1 question, that is state and explain Coulomb's law. And for 1 marks, define Coulomb. Define Coulomb. And now, limitations of Coulomb's law. It is important for 1 or 2 marks. Coulomb's law is only applicable to point charges. It is not applicable to extended charges, that is charges distributed on surfaces of body. It is only applicable to point charges only. Hence, for 2 marks, give the limitations of Coulomb's law. There are 2 limitations. It is only applicable to point charges. It is not applicable to extended charges. And define Coulomb. For 1 marks, define Coulomb, and for 3 marks, state and explain Coulomb's law in electrostatics.